is increasing, okay, if a function is increasing, let's say we have a graph that is going like this, okay, if you, okay, x1 and then get another portion there, sorry, x1 and x2, and then you are going to test it out, okay? Try to see if, compare their values in this function. If the values of x is increasing in all values of this interval, then it is going to be, the function is increasing. So we can determine this using our first derivative rule. So if y prime, okay, is greater than 0, okay, for all values in the interval, then let's use not y prime, let's use f of x, okay? F prime of x. Okay, for all values of x in the interval, then the function is greater than 0. So it is now increasing in that particular interval. Okay? The opposite of this is your decreasing function. So f prime, if you check your f prime of x, okay, lesser than 0 for all values of x in the interval, then the function is decreasing in the interval. Okay? This is now to test what's the behavior of a certain function in a given we have something like this. If we have here, we can verify this one by graphing. For example, we have something like this, and then the graph is going up like this over there, and then it goes down. Okay, and then I am now going to ask you, what is the behavior? What is the behavior of the function from negative 2? Hmm. So by confirming it to the graph, you can say now that the behavior of the function at negative 2, that's negative 2, until 1, until here. So what is the behavior within this interval? Okay, from here to here. What's the behavior? It is now going, as you can see, it's going, the direction is going down,
Oops. Yeah.
right? So by visual confirmation on the graph itself, it's very easy. You can say now that it is decreasing. Now, there's a disadvantage to this. Number one, what if you do not have, what if the graph is not given? You cannot see the graph. The function is given, but you cannot see the graph or increasing. Okay, there's a problem with that. If ever that you are going to be planning on entering university, during the entrance examinations, some universities doesn't allow students to use any calculators. Some, I'm not saying all, but some. Or the calculators that the universities allow you to use are not the graphing type. Okay. So if you are not allowed to use the graphing type calculators, then you cannot confirm or you cannot use your graphing software in order to determine the behavior of the graph. Okay, so it will also be difficult for us to or waste of time for you to graph this during a, let's say, 1 hour or 2 hour test. So what you can do, okay, is to use what we call your first derivative test, which is derivative of the function, and then compare the results. You test it out. If the intervals over here will give you positive results, then it is now an increasing. If it will give you a negative result, then it is now it is decreasing. Okay. What is the first derivative? If you try to go over our lessons, after taking the first derivative, what function is produced?
Is it the first
What
derivative?
function is that? When you take up again? Yeah, when
First,
that function
yeah,
belongs to what?
first order derivative.
Yeah, 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 and that function is what? It is again your gradient function. Once you take the derivative of a certain function, it is now a function that describes the gradient, correct? That's a gradient function, the gradient of that tangent. So it all ties with our lessons before. If the gradient like this, okay, if the gradient is going this way, the gradient is actually negative. That's the reason why the first, if it is lesser than zero, then that means it's a decreasing function. If you are taking it like here, okay, that's the tangent. The gradient of this tangent is positive because it's going up to the right. So that's the reason why that it tells you that if it is greater than zero, then it is increasing. You get the idea behind your first derivative test?
Yes, teacher.
Mm, okay, so this is just, I am just trying to tie your lessons with the previous lessons that we have learned before. Okay, so this is not entirely different. So let's do some examples. Mhm. There, let me just find a good example. Okay, here. Find the behavior of the graph of f of x equal to x cubed minus 3x squared, x cubed minus 3x squared minus 9x plus 11 minus 9 for value x. Let's just do this. Okay. So find the behavior of the graph of f of x plus x cubed minus 3x squared minus 9x plus 11 for values of or from values of 0 to 2. Okay, so it's just behavior. Is it increasing or is it decreasing or is there no change? Okay, so let's start. So no need to graph. All we need to do is to test using your first derivative test. If we have here f of x is equal to x cubed minus 3x squared minus 9x plus 11, your f prime of x is now going to be what? F prime of x is
3x squared
X squared
plus
minus 6x.
minus
6x.
minus, yeah, 6x
Mine
9.
plus 9. Oh yeah, minus 9. Yeah, I wrong.
Minus
I wrote the question
Okay.
wrong.
So from here, we just need to evaluate it or test it using our interval. Okay, we need to test it for values of x of 0, that's the lower limit, and 2. Okay, so let's start. Let's start testing. Okay, let's start. What will we get here? F prime of x is what? At x equal to 0, f prime of x, that becomes 0, 0, this one becomes negative 9. Okay? Clear?
Sure, shouldn't we exchange the x as 0?
Yeah, the 0, 0, right?
No, I mean the f prime x, shouldn't we change it to f prime 0?
Ah, yeah. You can write it as f of 0. Okay. You can write it as f of 0, or you can also write it as like this. You can write it as f of x 0. Okay, whatever is much more. I think my teacher used these symbols or notations before. Okay, the value of x is 0. How about f of, I'm going to use this, x of equal to what? If this is going to become 2, what value will we get?
Negative 9 as well.
Negative 9 as well. Okay, so we just tested the ends of the, or the limits. But according to this, for all possible values within the interval, if you are not, well, for me, I will accept this already. Okay, I'm the one taking the test. Okay, but if you want to make sure, you can also, you still have an interval in between, that's 0, 1, and 2, correct? You can also try f prime of x1. Okay, what do you get?
Negative 12.
Negative 12. Okay, so with this information that you have here, with this information that you have there, you can now make your conclusion. Is this an increasing function at this interval, or is it a decreasing function in this interval? It's all negative. Negative, negative, negative. So it is lesser than 0. So by definition in our test, if the value of f prime x, this one, is lesser than 0, then it's decreasing function. So we can now say that this is a decreasing function, f of x, okay? F of x is a decreasing function at the interval. Okay, so that's it. That's the conclusion that you can get. That means from 0 to 2, from x0 until x2, we have a decreasing function, meaning the graph might be going down from 0 to 2. Okay, but this is not actually the shape of the graph. It is just my guess. You get the idea, or what's the use of this?
Yeah, teacher.
Okay, so if you test it out like this and everything becomes positive, then you will say now that it is an increasing function. Okay, so let's move on. So now that you know how to determine or what's the use of your first derivative test, okay, we can apply this one to graphing. Okay, we can apply this one to graphing. Right. Since if we have a graph like this, we can now determine if at a certain point the graph is going down for decreasing, and we can now discover points or parts of the graph when it is now increasing. So knowing where it goes down or knowing where it goes up, then that is now a good indicator on how to plot the movement of the graph. You understand where I am coming from? Hmm?
Yes, teacher.
Are you still connected? Okay. So that's the plan,
Yeah.
however. But it's not enough to know where it goes down or where it goes up. So if we cut it into several intervals, okay, and we test if it is going up, so increasing here, so I know it's going up. Decreasing here, so I know